In this video, I will explain what an excitatory neurotransmitter is. Neurotransmitter molecules are released from nerves, and after the neurotransmitter molecule is released from the nerve, it diffuses toward the effector cell, the cell that neurotransmitter is going to impact its function. In this scenario, the effector cell could be a neuron or a muscle cell, and when neurotransmitter molecules get close to this cell, they're looking for their own receptors. They need to bind to their own receptors. When we say receptors, we mean some large protein molecules in the membrane of cells that neurotransmitters or hormones can bind to. And please keep in mind, a cell in its membrane has a variety of receptors. However, in this image, I just show you the receptors for this particular neurotransmitter molecule. We have a closer view of the receptor, and in this closer view, we notice that receptors are actually part of ion channel. Currently, the gate of this ion channel is closed, but we know when the receptor and the neurotransmitter bind together, that's the moment that the gate opens. And clearly we know that the ion channel, that opening its gate, depends on a molecule to bind to it, would be a ligand-gated channel. But before we follow what happens when this neurotransmitter binds to its receptor and open this ion channel, let's recall that in the membrane of neuron and muscle cell, we do have voltage, a voltage that can be measured in millivolt. And if you consider that the cell is at rest, its voltage is at resting voltage. Now the question is, when the neurotransmitter binds and opens the ion channel due to the movement of ions, what happens to the voltage of the cell? Does the voltage goes up toward the threshold, or does it move down away from the threshold? So let's see. The neurotransmitter molecule in our scenario binds to its own receptors that are part of ligand-gated ion channels, and then we see that the ion channel opens. And in this case, the ion channel is for sodium ion. We have a higher concentration of sodium ion in the interstitial fluid, the fluid that we have outside the cell. Therefore, sodium ion quickly start moving into the cell by diffusion. Since cell is receiving positive charge, when we follow its voltage, we see that its voltage start moving toward threshold. Recall that whenever the voltage of a cell moves toward threshold, we call that depolarization. So what we say here is that this neurotransmitter molecule, by opening sodium ion channels, allows sodium ion to diffuse into the cell, and as a result, the cell becomes depolarized, cell becomes excited. That's the main reason that we call this neurotransmitter an excitatory neurotransmitter. So in short, excitatory neurotransmitters lead to the depolarization of the cell by opening sodium ion channels.